Hello dear students, welcome back to NEET WORLD. So we'll be discussing organic chemistry right now. So this is our session on general organic chemistry here. So in this session we'll be covering inductive effect. See, in the last class, in the yesterday's live session, we have discussed how the basic chemical reactions are like taking place, like what are the basic things we need to know in order to make a chemical reaction, like how can we identify an electrophile, nucleophile. So after identifying only we can able to make reactions between them. So now tell me again, once again tell me, what do we mean by an electrophile and what do we mean by a nucleophile during a reaction? So electrophiles are electron deficient species. What I am saying? Electron deficient species, and these are electron rich species. Okay, so give some examples for electron deficient sites. See, you can say if I compare the elements having or species having electrons lesser than the octet configuration, it means if it has 8 electrons, then we can say it is an octet configuration. If this less than 8 electrons are there, then we can say them as electron deficient compounds. For example, here I am writing BCl3. How many electrons are there? Or BH3 or BF3 or anything you take here. Boron, the central atom is having now 6 electrons. Check here how many are there. So 2, 4, 6. So totally 6 electrons are only there around this boron with vacant orbital. So now BCl3 an example of electrophile. Like this we have neutral electrophiles and positively charged electrophiles. So the term here electrophile indicates electron loving species. What I am saying? Electron loving species. See, it will love electrons if it is deficient right now. So it is having lower electrons, less electrons than the required, then it will be looking for the electrons. That is what electron deficient species are considered as electrophiles. So now these are of two types, that can be a neutral and that can be a positively charged. What are the examples for positively charged? See, now I am writing here carbon with 3 bonds and 1 positive charge. See, carbocation is an example of electron deficient species and electrophile here. Okay, so now these electrophiles are there now, they will accept a pair of electron to fulfill their octet. See, BCl3, CH3 here I have mentioned. Now they have only 6 electrons now. Now what they will do? They will tends to accept 2 more electrons from other species and fulfill their octet. So why do we require these 8 electrons in them? Yes, they require 8 electrons. See, because if you write the electronic configuration of noble gases, something like 1s2, 2s2, 2p6, these are the valency electronic configuration of neon right now. So we will get a neon gas configuration, that is what noble gas configuration, if it is getting this total of 8 electrons in their valency. Okay, so that's why all the elements all the elements of this 2p series will be always tends to attain the last noble gas configuration, neon gas configuration, by attaining 8 electrons in their valency. So this is the main reason to fulfill their octet. So this is the main reason for the chemical reactivity of electron deficient species. Okay, I hope it is clear. Now these are electron deficient species, means now there are some species having more electrons with them. Now what they will do? Yes, they will donate that electron pair to these electron deficient sites. So what are the electron rich species I have given yesterday? See, something like any species like chloride ion, bromide ion, like this, any species having negative charge on it considered as nucleophile, or if it can be a neutral one having lone pairs with this. See, NH3 I have. Yes, so these lone pairs can be donated here, right? So now what I am saying, electron rich species that has electron density, that will be donated to the deficient sites. That's it. So simple. And guys, remember here, yesterday we have discussed the very basic discussion on this organic chemistry, and today I will be discussing the basic approach or electronic effects of this organic chemistry. In order to make chemical reactions, we need to understand what happening during the chemical reactions. What are the things forming, like what are reactive intermediates, how they are formed, if they are formed, how they can be stabilized. All these things we need to know now. Yes, for understanding that we are studying this inductive effect here. Okay, and one more thing guys, I can spend one full day on discussing of this electron like electrophiles, nucleophile, or this 10 minutes discussion is more than enough to understand electrophile, nucleophile for further understanding of this inductive effect. Okay, I hope you got that. Electrophiles means electron deficient site. I do not want to like want to waste your time, just look at here. Simple way we'll understand, so that we can move forward to the inductive effect, mesomeric effect, hyperconjugation and questions related. See, now after solving some, after like just 20 more minutes I will take, then after that I will show you the PYQ question directly. I do not want to waste a single minute also here. Directly we will jump on to the PYQs and we will solve them with whatever the concepts we have understood here. Okay, right, look at this. So for example here, during a chemical reaction I am writing CH3Cl, okay, and I am writing here OH minus. Okay, now look at this, when this chloride ion is going out, it is generating a positive charge on this carbon. Now can I say this is an electron deficient site? Yes, this is an electron deficient site. Why? Because this bond is cleaving, that is generating a positive charge over this carbon. That is nothing but it is having now 6 electrons only. If it is 6 electrons, if this bond cleaves, have only 6 electrons, becoming a electron deficient site. Therefore now what this carbon is looking for? Yes, someone who can able to donate the electron. Yes, see here OH minus is there. Yes, it can able to donate the lone pair electrons to this carbon. Yes, a new bond is forming between this carbon and this OH, therefore we will get a new compound like CH3OH, methanol we are getting, right? So I hope the concept is clear. So during a chemical reaction you can need to identify electrophilic center and attack with the nucleophile. That's it. This is the chemical reaction understanding way. Okay, right. Now let me tell you about this electronic effect, electronic displacements effect. Okay, so now with the help of this electronic displacements effects, we can able to understand the stability of the reactive intermediates. Okay, I will tell you all those things. Okay, and also how the reaction is going to proceed further, that everything can be understood when you got clarity on this electronic effects, electronic displacements effect. So this electronic displacements effect are of two types. Okay, one is a permanent effect, temporary effect. Okay, I will tell you everything here, just look. See, in organic compounds generally they have covalent bonds. What they have? Covalent bonds. So in that covalent bond, just now I have shown you carbon halogen covalent bond I have shown you here. So the electron pair in this covalent bond may undergo displacement either on their own or under the influence of attacking reagents. See, now here under their own, due to the electronegativity difference, the bond become polarizes towards halide ion with partial negative charge, and here partial positive charge. Okay, so this is how electron displacement is taking. Okay, so this displacement of electrons might be on their own or by the influence of some external factors. Okay, from external attacking reagent. If it is undergoing with respect to external attacking reagents, we can say them as we can say it as electromeric effect. It is in the presence of any attacking reagents, then we can say it is as electromeric effect. If it is just because of polarization of bond on its own, then we can say this is a normal permanent effects. Okay, I will tell you what are the permanence effects here. We have three permanence effects. Okay, permanence effects are three types. One is permanent effects are three types. One is inductive effect, and next mesomeric, and the next hyperconjugation. These are the three effects which must be studied in order to understand the complete organic part of first year and second year, 11th class and 12th class. Just follow the class. Today I will give you complete clarity on this inductive effect. Okay, and maximum amount we will discuss here itself about inductive effect. If anything remaining, we will shift to the next day. But let me show you some questions that what we are going to answer, solve after completing this session first. See here I have given phenols. We are going to answer what is the acidic nature of these phenols. How can we give the answer for this kind of question and this kind of questions? See, carboxylic acids, amines, again phenols, again carbocations. See, here I am not just giving you like question to answer. See, I am giving you the complete concept. After that, these are the things we are going to solve, because simple discussion won't give you much confidence right now. You need to know that what type of application it has and how we are going to solve them, right? So let's understand this inductive effect, right? Let's start this discussion on inductive effect. Okay, so let me tell you. So what happens in inductive effect is, see, when a carbon chain is there, like organic compounds means carbon chains are there generally, and these hydrogen atoms might be attached or some halogens are attached like that. So let us say here one group X is attached. So this X group is more electronegative than this carbon. What I am saying, group X is more electronegative than these carbons. If it is more electronegative, these bonded sigma electrons are taken by this halogen atom, and that is creating partial positive charge on this and partial negative charge on this. Up to here it is clear. So now the permanent displacement of sigma bonded electrons towards more electronegative atom is called inductive effect. Okay, the permanent displacement of the sigma bonded electrons towards more electronegative atom is called inductive effect. So when this electronic displacement is taking place, it is creating positive charge on the carbon chain. Okay, if this is positive charge, now see the adjacent one will be carbon here now. So now these bonded electrons are slightly taken by this carbon because it is positive charge now. Therefore, it will show some effect on it, and here I am writing double partial positive charge. And similarly, this carbon show effect on this, and it will be partial positive charge. It means effect will be more on first carbon, and it is decreasing to some extent on second carbon, further decreasing onto this third carbon, and on fourth carbon if we observe, the effect is almost negligible. So inductive effect is working up to first three carbons. After the third carbon, the inductive effect is almost negligible. Okay, it is something like if at a beach area, if consider it in a general life example, just imagine like this. See, if this is a beach area hit by a cyclone or a tufan, so what happens, we will be seeing the more effect will be at the seashore, I mean at the beach area, and it will be little more on the, little less at the far from it, like 100 meter, 200 meters. As we move away from that beach area, the effect of this cyclone or tufan will be less. Similar to that, if there is an electronegative atom attached to a carbon, it is more affecting on the first carbon, directly attached carbon, and as we move away from that halogen atom or the electronegative atom, effect will be decreasing right now. So I can say inductive effect is a distance dependent effect. What is that? It is a distance dependent effect. As distance increases, inductive effect decreases, that's it. So effect will works up to 3 carbons. At the 4th carbon, it is almost negligible. Okay, sir, what is the use of studying this? Yes, let me give you one example of inductive effect little more so that you will get clarity. See, I am writing CH2 plus here, CH2, CH2, Cl, CH2 plus CH2, CH2, Cl. Now look at this example 1 and 2, you will get some application of this inductive effect. See here, you have a positive charged carbon here and you have one more positive charged carbon over here. Now out of these 2 positively charged carbon, which carbocation is more stable? What I am asking, which carbocation out of these 2 is more stable? How can you answer here? See, this carbon is far from the carbocation by 2 carbons. Right now 2 carbons are there between these 2, between the carbocation and the chloride ion. So what is the use of having this distance? See, we know carbocations are electron deficient. What is that? Electron deficient. If they are electron deficient, they require someone who can donate the electrons but not who can drag the electrons from themselves. Right now, see, it is already electron deficient. If any electronegative group is attached, what happens? That electrons are dragged by that electronegative atom only. That means the positive charge will little more increased. If it is increasing more positive charge, its stability further decreases. Already deficient. If there is someone to give the electrons, it will be more stabilized. But there is no one to give electrons, but if any electron withdrawing group is present, that will be withdraws the electrons and that will destabilize the carbocation. So I am using a new word here, electron releasing group and electron withdrawing group. Okay. So if it is more electronegative atom, generally consider it as electron withdrawing group here. Okay, in respect of inductive effect. Okay, and if it is less electronegative, that will be releases electrons and we can call it as electron releasing group. See here, chlorine atom is an electronegative atoms here. If these chlorine atoms are more close to the carbon with positive charge, that will drag the electrons from the positively charged carbon towards this more electronegative chlorine atom. So now what is happening here? The deficiency on this carbon is increasing. If it is more deficient, more destabilized. If it is more destabilized, its system becomes unstable. So now what is the stability order? See, this is at the carbon, first carbon only we have chlorine, this is 1, 2, at second carbon we have chlorine. So which is more close? This chloride ion is more close to this carbocation now, it means this will be less stable now. So 1 is more stable than 2. I hope you got the concept of inductive effect, okay, application of inductive effect. If this concept is clear, just tell me clear in the chat box. If not, we will go with one more example, that is why I am asking. Whoever in the chat box can answer me. Yeah, whoever in the chat box can answer me this question. I am giving you one question, please answer me this. Based on the previous discussion, please answer me this one. Yeah, out of this A, B, C, which carbocation is less stable, or write their stability order. Write their stability order in these three compounds. Write their stability order here. So here you can see halogen atoms are there, and there is nothing here, only carbocation is there. So all these carbocation carbons are electron deficient. But which is more electron deficient? See, one which is having more electronegative atom, that electronegative atom drags the electrons and creates more deficiency on this positively charged carbon. If it is becoming more deficient, then that will be less stable. So which is less stable here? This is more electronegative atom now, fluorine. So that will drag the more electrons towards itself. So it makes it to be more electron deficient, so less stable. So C is less stable than B, and more stability is relatively for A. That's it. This is the order of this stability of this question. Okay. Hope the discussion is clear. Now what I told you here, so I have explained about this inductive effect right now. So now this inductive effect is of two types. What I am saying, inductive effect is of two types. One is positive inductive effect and negative inductive effect. So positive inductive effect means, just see here, the permanent shift of electron density from electron donating group towards the carbon chain. Here permanent negative inductive effect means from the carbon chain, that electron density will be shifting towards electron withdrawing group. It means, for example, here I am writing a carbon chain. This is a carbon chain having a group G. I am calling this group G as electron releasing group. Similarly here I am calling a group G dash as electron withdrawing group. So what this electron withdrawing group and releasing groups do here? If it is a releasing group, that releases electrons into the carbon chain like this. Okay, but here I have electron withdrawing group now, so that will withdraws electrons from the carbon chain towards itself. Okay, so what you are understanding from this, if there is any electron releasing group is present, that increases electron density in the chain. So if any positive charge is there in the chain, then electron releasing groups help that carbon with positive charge by donating the electrons. Those groups are called electron donating groups or electron releasing groups. So here electron withdrawing group is there. For example, here a positive charge is mentioned. Now what happens, this withdrawing group, whether it is positive or negative, no matter, this fellow will withdraw the electrons from the carbon chain. So now what happens to the carbon, positive charged carbon, its electrons are already deficient, now it becomes more deficient. If it is more deficient, less stable. So I can simply say one application of inductive effect is electron releasing groups or plus I effect which increases the stability of carbocation. Stability of carbocation is increases by electron releasing group. Now I am placing the I am replacing this carbocations with carbon anions. What I am taking here? Carbon with a negative charge. Here also carbon with some negative charge. Now tell me what happens. See, carbon with negative charge means here electron density on the carbon is more. On the carbon chain we have more electron density. So now we required a group that will withdraws electrons from that carbon chain. Therefore, the carbon anion will be stabilized. It is something like reverse of carbocation. So now here we have an electron withdrawing group. Now what it will be doing? It has a nature to withdraw that electrons from the carbon chain. If it is withdrawing the electrons from carbon chain, the stability of carbon anion will be increased. Why? The electron density here, instead of sitting on one carbon, it is shared towards this group G, electron withdrawing group side. Therefore, its stability increases. So carbon anions stability increased by electron withdrawing groups. With what? Electron withdrawing groups. If it is a carbon anion having electron releasing group, what happens in this scenario? It will be destabilized. Why? Because carbon anion means negative charge. So this negative charge again already having more electron density, and this is electron releasing group. If it is electron releasing group, releases electrons into the system, already negative charge, and this fellow is releasing electrons, becomes more electron density now. That small size carbon already bearing too much electron density, and this group is releasing electrons towards it. Therefore what happens to the electron density? Again further increased. If electron density is increasing, carbon anion stability decreases. Okay, so its stability decreases when we have electron withdrawing groups. So carbocation stabilities are increased by plus I effect, and plus I effect decreases carbon anion stability. It is both of them are of a reverse. Okay, if carbocation stabilized, carbon anions destabilized. So this is the thing you need to know here. Ishwar Kolanupaka. Yes, Ishwar, sir, I am watching your previous videos of MCET series. That videos are good to understand. Please continue till the exam. Definitely, Ishwar, this series of MCET, I mean MCET live sessions are going for till the exam. Okay, so even IP discussions are also going here. Okay, from December 12th we are going to start even IP classes also. So for both MCET and IP we are making it parallelly. So do not worry about the sessions. Okay, just make your preparation very effective using our sessions, free live sessions. Okay, and one more thing I will suggest you, Ishwar, I don't know from where are you from, but you just share these videos with your friends who are looking for MCET. Okay, those who are planning to prepare for MCET, whether they are BPC or MPC, no matter, just share with them. Okay, just share in your school group or in your college group, then they can get more usefulness from these sessions, because some of the students are looking for IP preparation. Yes, from December 12th we are coming up with free live sessions on IP, and some students are looking for MCET. So MCET also we are discussing here. So as we seen, we have almost 100 videos on chemistry IP, I mean chemistry MCET from 2025 and this year. Okay, so for this year I have started around in the first week of November, and it's almost 1 month I have covered lot of topics. Okay, so just use all those things and make your preparation more effective. Right. Okay, then next. So the next, see up to here it is clear now. So now what I am saying here, a carbon is there with positive charge. Here it is attached with one carbon. Now I am giving one more CH3 positive charge. Now tell me, out of these two, which is more stable? Which is more stable? Which is more stable? How can you decide that? See, to the carbon, positively charged carbon, directly carbon only attached, right now. See, a carbon with positive charge means a more nuclear charge than carbon with neutral, right now. So if it is neutral, this is positive charge, means definitely a positively charged carbon will be having now more tendency to drag the bonded electrons towards itself. So therefore, the alkyl groups here shows plus I effect. What effect I am saying? Plus I effect. What do we mean by plus I effect? Electron releasing nature of this group. Whatever the attached group is there now, that will releases electrons into this positively charged side. Okay, so it is releasing electrons, means I can say this group as a plus I group. Okay, similarly here you can see this is one plus I group and this is also one more plus I group. So how many are there now? Two plus I groups are there. Okay, here only one plus I groups are there. More the number of plus I groups, more the number of electron releasing groups, more is the stability of that carbocation, right now. So out of this A, B, which is more stable now? B is more stable. Clear now? So now based on this, you can directly solve this question without any gap. Just tell me what will be the stability order, stability of these four options, like which carbocation is more stable. See, forget about this question. What I am asking, out of these four options, which carbocation is more stable? Tell me first. If you are able to arrange the stability, then you can answer this the one step more forward question, this one. Okay, so tell me which carbocation is more stable here. See, here option A is a primary, option B is tertiary. Three alkyl groups are there like this, and this one is secondary. Two carbons are there, this side, and this is primary. So what we know, a carbon having positive charge, if it is surrounded with more number of alkyl groups, that will be more stabilized. So I can say B is more stable, and after B, see here you have only one side alkyl group, this side two alkyl groups. So the next C is more stable, and here this is primary and this is primary. Okay, so in order to answer this between A, D, we need to study one more effect, that is hyperconjugation, that we will be discussing in the next session. But up to here it is clear now why B and C, B is more stable? Yes, because more number of alkyl groups are there here. Okay, so based on this understanding, see what happens, which of the following is most stable form of the given structure after the rearrangement. See what happens, that kind of rearrangement, what happens, see here, see carbon, CH3, and here H, and here CH2 plus is there. So like this it is there now. So if I shift this hydride ion from here to here, what happens? The primary carbocation can be rearranged to tertiary now. CH3, CH3, CH. If this hydrogen is going here, you will be getting one more hydrogen over here and positive charge. So this is a tertiary right now. So if it is tertiary, that will be more stabilized. So that's why the whenever you know like stability of carbocations, you could able to solve how the reaction also going to proceed further. See, I can make a question on this. Like this they will give. Like this they will give OH and HBr they will say. So now what is the product they will ask. So basic understanding of inductive effect will help you to make this reaction properly. See now what happens, this OH and this H plus removed as water, so that you will be going to get a positive charge on this carbon, right now, like this CH2 plus. So if this is a positive charge, now what is the other species here? We have bromide ion. So this bromide ion need to attack here. But what type of carbocation it is formed? Primary one. Na? So primary are less stable. Now we can make it more stable by shifting one of this group over from here to here, and it becomes positive charge here and methyl group here. See, this is becoming tertiary. Which is more stable carbocations here? Tertiary. Na? So that's why this kind of rearrangement of carbocation takes place by a group shifter. It can be a hydride ion in this way, or it can be a methyl group in this way. If there is no hydride ion, methyl group shift is taking place. If there is hydrogen, then definitely most of the cases this is hydride ion only shift. okay, because bond strength here for CH is less when we compare with the CC. That's why CH bond easily breaks and shifts here, okay, migration takes place easily. So this will now be giving us the major product like this. See, positive charge wherever we have, there you add this bromide ion and make a compound like this. This is your final product, okay. So this is how you need to understand the concept of inductive effect application, okay. So do not by heart the things just for the namesake, or sir will be putting an exam on this particular topic, means do not by heart it, okay, or just for IPE purpose, do not study in that way, okay. So try to learn the concept. If it is unable to get at one time, do not by heart for the exam. Read it one more time, or read it one more time, or go to someone who can help, or you can have online videos, many videos are there. So use these things properly and make it more effective way of learning, okay, right. Okay, let me give you few more things. Now I told you there are two effects, one is plus I effect, another one is minus I effect. So plus I effect is shown by those groups which can able to donate the electrons, right now, which can able to donate the electrons. If I am writing a carbon chain like this we have written. So here I am attaching a group G. Now this group G can be any of these, this G group can be any of these. See, if you observe all these things, what they are having, see, these groups are having minus on them. If this any G group having negative charge on it, considered as or act as electron releasing group, okay. If G group is having any negative charge on it, more electron density, that will releases electrons into the chain, then we can say it is a plus I group. What is that group? Plus I group, okay. See here, NH minus, O minus, COO minus, like that, okay. And along with this, if any neutral groups, but that should be made up of alkyl chains like carbon only, see, like this carbons only, then we can say that is also electron releasing group, okay. Now more the number of carbons here, more is the releasing nature of this carbon, okay. So tertiary like tertiary alkyl groups are more plus I effect, having more plus I effect or more releasing nature than the remaining things, like that, okay. So this is an experimental order for plus I effect. What is that? Plus I effect. Again, once after getting clarity on inductive effect, you need to study about hyperconjugation, okay. So there the things will be little differ, okay. That makes you feel confused at a time when you see the application of hyperconjugation and application of inductive effect, because there are little variations are there, but I will give you complete full clarity on that, okay. Do not worry about that, okay. So now similarly, okay, let me give you one application over here on this. See, now I have a carbon sign here, CH2 plus, CH2, CH2 and NH minus, and the next CH2 plus, CH2, CH2 and COO minus. Tell me which is more stable carbocation out of these two. Which carbocation is more stable? Which carbocation is more stable out of these two? Which is stable carbocation out of these two compounds which I have mentioned here? Yes, someone, Nivedita in the chat box, you can answer, ma'am. Yeah, see here we know inductive effect of NH minus is more than COO minus, right now. So now if it is more inductive effect plus I effect, if it is having more plus I effect, it will releases more electrons na easily. So but here what we require, carbon with positive charge, means this is also required more electrons only na, that requires more electron density to stabilizing the carbocation. So now NH minus is more releasing group than this COO minus, therefore effectively stabilized one is A. So A is more effectively stabilized than B, therefore I can say A is more stable than B. Hope you got what is the application of this like order in the questions. Right now you can see not only NH minus COO minus, anything out of this might be given in the exam and may ask for the questions like this. Okay, and similar to this we have one more effect called minus I effect, that is plus I, this is minus I. It means what? Again you can take a carbon chain like this, you can take a carbon chain like this, you can add a group G, this group G can be any of this now, any of these compounds, any of these species. Okay, now if they are attached, what they will do? See, these groups are having positive charge, in previous case they are having negative charge. If these are positive charge, now these are only required electrons because they are positively charged, they required electrons from the chain. So if they are required electrons from the chain, so what happens to the electron density in the chain? Electron density in the chain decreases when we have these electron withdrawing groups, those are minus I groups. Okay, let me show you one example question for this. See, I am writing CH2 plus here, and here one NR3 place, and one more I am writing here CH2 plus CH2, and here Cn. Tell me which is more stable here out of these two, which is more stable out of these two? Yeah, tell me which is more stable. As per the order, if you see, cyanide is here and NR3 is here. So which is having ability to drag the electrons towards itself? See this fellow NR3 plus, right now. So if NR3 plus is attached, that will be having more tendency to drag the bonded electrons towards itself when we compare with the cyanide. Okay, so here carbocations are there. These are carbocations are electron deficient. Okay, these two of them are carbocations only, both of them are electron deficient, attached with different groups here, different plus I, minus I groups. So now minus I groups decreasing electron density from the ring, already these are deficient, these fellows are making them to too much deficient again by connecting to them. Therefore, the electron deficiency is more, it is becoming more when we have attached this NR3. Therefore, which is less stable here? So stability of this carbocation is further decreases when we add this NR3 because it has more ability to drag the bonded electrons. Therefore, between A and B I can say A is less stable than B. Okay, this is how you can use this order to solve the questions. Okay, now same question I am using one more application. Here I mentioned positive charge. Now let us take negative charges. Carbon anions case we will take CH3, CH2, CH2, and here one NR3 group and one more is CH2, 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 and here Cn. Okay, negative charge. So tell me again here which is more stable, carbon anion, which is more stable out of these two? Remember here when it is having a negative charge means more electron density on these carbons. Okay, so now always the negatively charged species required someone to drag that electron density towards themselves. See, we have two groups here to drag the electron density, but which is dragging that electrons more effectively? NR3 as per this experimental order. Therefore, this carbon anion is more stabilized due to minus I effect of NR3 plus when I compare with the cyanide. Therefore, A is more stable than B in this case. Okay, if I say AB, A is more stable than B because more minus A effect of NR3 plus when I compare with the Cn. That's it. This is the application of inductive effect in case of carbocations and carbon anions. Okay, right. Then next, in similar way, we have few more applications to discuss for this inductive effect. What I discussed till now, we have discussed relative stability of carbocations and carbon anions. Those are nothing but intermediates during the chemical reactions. And the next we have acidic and basic strength of organic compounds. So what is this acidic and basic strength? For example, I am giving you an acid here. See, This is a carboxylic acid. Okay, here I am writing one more carboxylic acid like this. Both of them are looking same now. Let me add here one nitro group. Here no group is there, and let me make one more question. Here one CH3 group I am adding. So I am saying ABC. Out of this ABC, which is more acidic? All of them are acidic, but which is more acidic? Which is more acidic? How do we know that? We can get to know that by looking at the stability of conjugate base formed. What do we mean by conjugate base? If this H plus ion comes out of this carboxylic acid, what is the remaining species formed? See, acidic nature means that should release H plus ion only now. So H plus ion is released here and forming this conjugate base. Now we need to look for the stability of this particular conjugate base. If this conjugate base is more stable, then I can say this acid is more acidic. Okay, so this will be a weak acid. Equilibrium symbol you should maintain. Now if it is more acidic, its conjugate base will be more stable. If this is more stable, then this is more acidic. This is what you need to remember. If a conjugate base is more stable, then equilibrium moves forward, that indicates the given compound is more acidic. So now out of these three, which is having more stable conjugate base, which is forming more stable conjugate base? See, if I remove this negative charge, we will get a negative H plus, we will get a negative charge here, and here also we will get a negative charge after removing this H plus. Here also we will get negative charge with like this conjugate base. Now this negative charge must be withdrawn towards themselves, that makes it to be more stable. See what type of group I have here? Nitro group. Nitro group have ability to withdraw the electrons. That is what? Electron withdrawing group that I have shown you in the previous case. That is minus I effect groups list I mentioned there. Okay, so it will be withdraw the electrons from here and stabilizes this negative charge. Okay, and here if you see there is no such groups, but here some other group is there. What I told you about alkyl groups are nothing but plus I groups. These fellows will release the electrons into the system. Already negative charge is there, and this fellow is also releasing electrons into the system, making more negative charge and more electron density. If it is becoming more electron density, system becomes less stable. Therefore carboxylic acids, acidic nature of organic acids, organic compounds increased by electron withdrawing groups or minus I effect. Okay, whenever there is minus I groups are there like this, their acidic nature is more. So you can say C is more acidic than B than A, that's it. Okay, this is the application of inductive effect here. Okay, let me show you some questions. Answer me this, which is more acidic out of this ABC compounds? Which is more acidic? I know you can easily answer if you have followed the class. Yes, I am expecting answer from someone in the chat box. Arrange the following in the decreasing order of their acidity. So which is more acidic here? See, I have SCN, I have F and NO2. See, we know all the cyanides, fluorine and nitro group, all of them are minus I groups only. We know minus I groups increases the acidic nature of carboxylic acids, right now. So now, but which is stronger minus I group out of these three? Nitro group. If you want, take the help of this sheet. Try to make this list of this sheet like minus I groups and plus I groups, so that you will easily solve the questions. See, where do we have nitro group here? This is nitro group. After that we have cyano group, and least here somewhere else here fluorine is there. So ability of withdrawing is more for nitro group, then next cyanide, then next here fluorine. So as per that question, what will be your answer? So for this particular question, what will be your answer? See, nitro group is there now, that increases more acidic nature here. So C will be more, then next here cyanide and fluorine. Cyanide will be then B, CAB, CAB. Okay, B, option B your answer. Okay, similar to this, I will be showing you one more question. But this is for phenols. This is for phenols. This is for phenols. Tell me, in the phenol case also they are asking about their acidic nature. Whenever I mentioned a common statement, carboxylic acids, not only carboxylic acids, organic acids you can take, any organic acid is there, its acidic nature increased by electron withdrawing group, that is minus I group. Okay, so what type of group attached here? Nitro group. Here also nitro group, here methyl group. See, one more effect we need to learn here, that is mesomeric effect, in order to understand why 3, 4 are having different answers here. I will tell you that later, but as of now, what will be the more acidic here? We have electron withdrawing group here and here. So definitely these two will be having more acidic nature when I compare with 1 and 2. Okay, between 1 and 2, here it is electron releasing group. Due to this electron releasing group, acidic nature of phenols decreases. So I can say 1 is more acidic than 2, and between this thing, 3 is more acidic than 1 and 4 is more acidic than 3. Okay, so we know 1 is more acidic than 2, 1 is more acidic than 2, and 2 is the next 1 is less acidic than 3 and 4, 3 and 4 here you have and here you have, but option 4 will be your answer. To differentiate these two things, I mean to get clarity on these two things, you need to study mesomeric effect, that I am going to teach in the upcoming classes. Okay, so again let me give you some clarity, those who are watching with some idea on mesomeric effect, I will tell you. See, whenever nitro group is at para position, see 1, 2, 3, 4, so this fourth position with respect to OH group is called para. So if this electron withdrawing group is at para or at ortho positions, then this electron withdrawing nature is more. Mesomeric effect will be applicable only at ortho and para positions. Therefore, that will be more stabilizing this phenoxide ion of this particular phenol. That's why 4 is more acidic than 3. Okay, so final order will be 4, 3, 1, 2. That's it. This is your answer for the question. Okay, next. Can you answer me this? Can you answer me this? See here, in order to answer again you need to know mesomeric effect. Anyways, keep it aside, just answer me for between 1 and 2. So what I told you, alkyl groups are releasing groups, and this is, there is no group here. So if no group is better than having electron releasing group when we are talking about acidic nature, because either we require electron withdrawing group to increase the acidic nature of carboxylic acids or phenols, but there is no electron withdrawing group, but here we have releasing group. So releasing group means less acidic than no group. Okay, so 1 is more acidic than 2, 1 is more acidic than 2, 1 is more acidic than 2 only in this option. So option C will be your answer. Sir, how can we answer between 2, 3? Yes, that requires you to study mesomeric effect, that I am going to explain in the upcoming sessions. Okay, now just tell me here CH3, CH2, CH2, COOH, acidic nature of these compounds, you tell me. Here I am attaching fluorine, here I am attaching fluorine, here there is no group attached, here there is no group attached, and here I am attaching fluorine. Tell me which is more acidic here? More acidic here out of this 4. A, B, C, D, you take A, B, C, D. Which is more acidic out of this? See, carboxylic acidic nature is more when there is electron withdrawing group. here we have electron withdrawing group, here we have electron withdrawing group, but it must be very close, then effect of inductive effect will be more. So inductive effect, minus I effect will be more when it is very close. So as distance increasing, inductive effect decreases. Therefore, more acidic nature is for D, C, B, A. This is your answer for the question. Okay, this is your answer for the question. Okay, now I can make the question in the similar manner by replacing these halogens. So if I place a chlorine atom here, instead of fluorine, placing a chlorine. So between this and this, tell me between this C and this E, which is more acidic between C, E? Tell me which one? See here, fluorine is less more electronegative than chlorine. Therefore, more electronegative, more withdrawing nature. So C is more acidic than E. This is the way you need to make the answers. Okay, right. And the next, here I can explain basic nature of amines also, or NH2. Amines, these are amines. So amines basic nature is due to presence of these lone pairs. Okay, so they can accept H plus ion using these lone pairs. If they have more ability to accept the H plus ion, more basic nature we can say. Now I am writing here I am writing R, it means R indicates one alkyl group like CH3 group. Okay, CH3 group, and here I am writing CH3, CH2, CH3, like this I am writing a lone pair on this, and one more I am writing here CH3, CH2, CH2, NH2. See, both of them are having same number of carbons, same number of like carbons and nitrogen, hydrogens, everything. Okay, I can say those are isomers. Now, but out of these two, which is more basic? Which is more basic? See, what I told you, acidic nature means tendency to accept this H plus ion. Which of these amine having more tendency to accept this H plus ion? That is a question. Simple way to understand is, if these electrons are freely available to accept, then that is more basic. Now, see that electron density will be increased when there is electron releasing groups. See, alkyl groups are there, those are releasing groups only, but here we have two sides alkyl group, one side from here and here. So both sides alkyl group increases more electron density on nitrogen, readily accept this H plus ion. Okay, but here only from one side we have alkyl group. Okay, so more electron density increased here by 2 plus I effects. So I can say A is more acidic than B, more basic than B. Okay, so basic nature of amines, basic nature of organic bases. You can say amines or whatever might be organic bases. I am simplifying, I mean generalizing. Okay, basic nature of organic bases increased by electron releasing groups. If there is any electron releasing groups are present, that will increases basic nature of amines. Okay, if you want, you just look at this one PYQ question to get more clarity. See, here you have nitro group, which is minus I group, we know. Okay, here you have methyl group, which is plus I group, we know. So now tell me what happens. Again, one more thing, let me show you that example here. NH2, NH2. Now just answer me this before answering that. AB is there here. Which is more basic here, and B, C? NH2. Out of this ABC, which is more basic here I am asking. Okay, so what I told you, if there is any withdrawing groups, minus I groups, that will decreases the electron density of these amines by dragging electrons towards itself. So these are less available to accept H plus ion, so its basic nature is less here. So B is the least, you can say. Between AB, we have bigger alkyl sign here, so it will be having more basic nature, and here A, back, BAC will be the order of basic nature. And here in this case, you can see nitro group is there, along with this lone pairs are in conjugation with the ring. So now it is less available to accept this H plus ion, so it is least basic. So C is the least basic. Between 1 and 2, if you observe, these lone pairs are not in conjugation with the ring, they are free to accept H plus ion. So B is more basic out of these two. And here these lone pairs are in conjugation, and this is plus I effect. Okay, so relatively when I compare with C and A, this is plus I effect now. So plus I effect increases electron density on this nitrogen and can easily accept proton when I compare with this. So A comes in between. Okay, and between AB, you can remember this is an aliphatic amine. The conjugation and the lone pairs are not involving in the conjugation. So it's an aliphatic, this is aromatic. So aliphatic amine is more basic than this aromatic amines. That's why you are going to get this kind of basic nature order. So where do we have CAB? So C, which is more here, more basic is B. Okay, B, okay, which is more basic here, B. B more basic is B. Okay, after this B, A should be more basic. Yes, A should be more basic. Yeah, but there is no option, no. Definitely this will be the answer for the question. Okay, so B is more basic, aliphatic amines are more basic, yes, aliphatic. Between these two, here releasing group is there, that increases the basic nature of amine, yes, B here. And this is withdrawing group that decreases the basic nature of amine, then that should be least. So this will be perfectly correct answer for the question. Okay, right. Okay, I hope you have enjoyed this session, and if you want, you can practice few more questions here I am giving you, and tell me your answers for them in the chat box. See, carboxylic acid this one, and one more this one. Okay, remaining discussion and questions related to inductive effect all together will combine with the mesomeric effect and hyperconjugation once after studying all the effects. Okay, I hope whatever the discussed things are there till now, everything is clear. If you are having any doubts or any confusion, just mention me in the mention in the chat box. I will definitely look into it and I will respond on it. Okay, so thank you for watching. Stay connected with our NEET World YouTube channel, and you can share with your friends who are preparing for JEE, NEET or EAPCET exams. Thank you.